Alright, example 3, another optimization problem. Let's jump into it. It says a rectangular page is to contain 24 square inches of print. So here is 24 inches of print, 24 square inches of print. So we'll say area of page would be x times y equals 24. Then it says the margins at the top and the bottom are to be 1.5 inches. The margins on the left and right are to be 1 inch. What should the dimensions of the page be so that the least amount of paper is used? So we've got the area of page, that's wrong. This should be area of print. And then area of page. So this distance here would be x plus 3. This distance here would be y plus 2. And we'll just call that a since we don't know what that is. That's what we're going to try to optimize. We're going to try to figure out what should the dimensions of this page be to give you the least amount of paper used. So we want to write this in terms of x, so we want to replace y equals something in terms of x. So we'll use this equation, solve for y. We're going to get y equals 24 over x. So a of x equals x plus 3 times 24 over x plus 2. And now I'm going to multiply here. A of x equals 24 plus 2x plus 72x plus 6. A of x equals 2x plus 72, x to the negative first, plus 30. That's going to be the function that we're going to work with here. Now, in order to figure out the relative min, we're going to find the critical numbers. In order to find the critical numbers, we're going to have to take the derivative of this function. So this is going to be 2 minus 72x to the negative second. Okay, derivative of 30 is 0. Then to find the critical numbers, we're going to see if we can set this derivative equal to 0 and find an x value where to make this true. See if we can do that. So this would be 72x squared equals 2. Cross multiply, you get 2x squared equals 72. Divide both sides by 2, you get x squared equals 36. Square root both sides. X equals plus or minus 6. Okay, so it doesn't make any sense x could be negative. So we are going to try x equals 6. Also, does it make sense when x would be 0? That would make this derivative does not exist. But 0 doesn't make sense. There's got to be some positive value here, so we're going to throw that out. So now, looking at a number line that represents x, it's got to be somewhere between 0 and infinity. 6 being right here. We want to see if this 6 is a relative min or max. I'm going to do that by using the second derivative test. So I'm going to take the second derivative of this, which would be 144x to the negative third, which is 144 over x cubed. And then let's test. A double prime of 6, that's going to be positive. That's going to be greater than 0. So this is going to be concave up. Okay, so this is concave up. At this point here, this is going to be a relative min. Okay, and then to answer the question for dimensions of the page, okay, we would do 6 here. 6 plus 3 is 9 inches. And y, so we got to solve for y, so I plug 6 in there, that's going to be 4. 4 plus 2 is 6, so this would be 6 inches. That would be the dimensions of the page. That would be the least amount of paper used.